get rolling. Today's the 31st. I'll take any questions. Go ahead.
I have a question on 7.4.
Go ahead.
Number 5, find the indefinite integral by using the substitution x equals tangent theta.
Okay.
And the problem is the integral of x squared over 1 plus x squared squared dx.
X squared over 1 plus
No.
squared over.
Squared. I can't say it.
You can't say, oh.
No, it's x squared over the quantity of 1 plus x
Oh.
squared.
X squared over the quantity of 1 plus x squared squared, like this?
Right.
Okay, let's take a look. Hey, Lewis. It's a trig substitution problem. X equals tangent theta. You have a 1 plus x squared. It's an a squared plus u squared form. That x equals tangent theta. Derivative tangent, secant squared. Substitute in x squared, tangent squared. 1 plus tangent squared. Squared. Dx is secant squared. The point is make the substitution and hopefully arrive at an integral that can be done, as opposed to the first one, which can't be done. Okay? Well, what's 1 plus tangent squared equal to? Okay, secant squared. The point of making that particular substitution is to replace this with the secant squared squared, which is a secant to the 4th. And now we can cancel a couple of secants out to end up with tangent squared over secant squared. Bless you.
Thank you.
Well, now the thing to do is see if you get something simple. If you let u equal secant, the derivative of secant is secant tan, and you got a tangent squared up here, and that's not good. If you let u equal tangent, derivative of secant squared, if this were up in the numerator, we'd be done. It'd be u to the n form, it'd be pretty simple. But it's down here where we can't use it. You have a couple of possibilities here. One possibility is to go to sines and cosines. And I said, as a general rule, if you get tangents and secants, and it's not immediately apparent how to do the integral, which you can let u be and find the du, go to sines and cosines and see what happens. So that's what I'm going to do. Okay. Tangent squared is sine squared over cosine squared. Secant squared is 1 over cosine squared. Well, that's nice. Because the cosine squares will then cancel. And you have the integral of sine squared, which we can do. How do we do the integral of sine squared? What do we do? What is it? No, because you don't have a cosine to go with it. It's not u to the n. What do you do for sine squared? What is it? No.
Half substitution.
Yes, half angle substitution. Okay. Sine squares and cosine squares, half angle substitution. What's sine squared? It's 1/2 the quantity 1 minus cosine 2 theta. That's sine squared. I really would expect you to know that. Okay. On the test, you can bet that there will be an integral of sine squared or integral of cosine squared. Those are fundamental. You should know. You got to know both of those. Okay. I won't give you both, but I'll give you one of them. Okay. 1 minus cosine 2 theta. That's sine squared. We could take the 1/2 out front, and now we can integrate this. You integrate 1 d theta to get theta minus cosine 2 theta. That's a cosine u form. U is 2 theta. Du is, bless you, 2 d theta multiplied by 2 and by 1/2. You'll have 1/2 cosine u, and the integral is sine u. Okay? And plus c. Okay? So, you get this 1/2, take it out front. The integral of 1 d theta is theta, minus, and when you integrate cosine 2 theta, it's a cosine u form. Here, let me just show you. Let's make sure we're okay here. What do you do for this? You let u equal 2 theta. The du is 2d theta. Multiply by 2 and by 1/2. Gives you 1/2 the integral of cosine u du. The du being 2d theta. That's 1/2 the integral of cosine is sine. That's where this is, right here. Okay? All right. The good news is we're done with the integral as far as that goes. The bad news is it's not in the right form. Okay? We've got to get this back to x's again. Okay? We have to get it back to x's. So, we have a 1/2 theta. What the heck is theta in terms of x? What? We have to push it up?
Or down and then.
Oh, down? Oh, yeah, okay, there you go. Okay. What is theta equal to? X? No.
Arctangent.
Thank you. Arctan x, theta is arctangent. Take the arctan of each side. You get theta is the inverse tangent, arctan x. So you have a 1/2 arctan inverse tangent x. That's what theta is. How do you find theta here? You do the inverse function, inverse tangent. Take the inverse tangent of each side. Minus, now you've got a 1/2 sine 2 theta. Oh man, we have x equals tangent theta. We got a 2 theta here. What you should do is use a double angle form to get rid of sine 2 theta. What's sine 2 theta equal to in terms of sines and cosines?
2 sine theta cos theta, right?
Yeah. Yeah. Good deal. Okay. All right. We got 2 sine theta, cosine theta. The 2's cancel. So we get sine theta, cosine theta, plus c. Okay. I take the 1/2 times the 2. Sine 2 theta is 2 sine theta, cosine theta. Now I can get it back in terms of x's. I have x equals tangent theta. I want to get back to sines and cosines. What do? How do you get back to sines and cosines if you have the tangent? What do you do?
What's up?
What'd you say?
I was saying no space.
Oh. Okay, what do? You got x equals tangent theta. We want sine theta. We want cosine theta. How do you get back to x's? What do?
Oh, right triangle.
Right triangle. Yeah, I thought
It was there.
it was there. I saw it. I saw it there.
Yeah.
X equals tangent theta. Call this theta. The tangent of theta is the opposite over the adjacent. Make it equal to x. Okay, that's what this says right here. X is tangent theta. Tangent theta is opposite over adjacent. You make it x. Solve for the hypotenuse. Square root of 1 plus x squared. Once you do that, you can find the sine of this angle. What's the sine of this angle? The sine is opposite over hypotenuse. The cosine of this angle is the adjacent over the hypotenuse. Okay? And you probably shouldn't leave it like that. Square root times the square root. You drop the square root. So, your final answer should be 1/2 inverse tangent x minus x over 1 plus x squared plus c. Okay? You should be able to put that in and have WebAssign say, yeah, or whatever it says if it's right. Okay? Make sense? Now, there's a lot to a problem like that. And, on the test, I'm not going to give you one like that. The probability of making a mistake along the way is pretty significant, okay? It probably approaches 1. So I wouldn't give you something like that. Matter of fact, I'm going to tell you what I'm going to give you on the test. Here's what I'm going to give you on the test. I would give you this integral on the test, but I would ask you what trait substitution should be made. That's the question. It's kind of wimpy, I know.
Well,
Wait, are you insulted by this? Yeah. Yes, you are.
do you want to pull
See
the
it?
sheet-
No? Okay.
I'll pull the sheet down just a little.
Oh. Oh, wow. Holy mackerel. Well, wait a minute. Let me zoom in. Otherwise, I'm going to be doing this all night. Let me. Oh, you can't zoom in once you're recording. All right, stop recording.